Hi, Todd Cooper here in San Diego, America's finest city. I'm giving you our May update for 2022. We do this 3 times a year in January, May, and September as part of our joint IEEE IHE-HL7 Devices Working Group Meetings. So hang on, we got a lot of information to cover. Now, the topics for today are what has been the activity since January to May, so just the last few months. General project updates. I'm not going to go into a lot of detail on it, but you'll get the big picture. And then what about the update on the requirements interoperability, model-centric, regulatory submission ready initiatives, specifically around conformity assessment and tooling strategy. We'll go into a bit more of a deeper dive on that. And then the ecosystem pathway group. We launched it last September. We worked on it to January, and now it's operational. So what exactly are those guys up to? We'll cover that. There's a topics of interest review. We'll hit on some of the topics, but especially the process that we're using, which we documented a bit better, so you might understand it better. And then some couple of very clear focus areas. One is IHE devices OIDs, the OID naming space, and how we're going to use that to support SDPI extensions, which are necessary for some of the messages. And then finally, a really quick look at the various GitHub repositories that we're now using in this space, as well as publication to profiles.ihe.net/devices, something that is very new, just happened a few weeks ago or days ago, actually. So without any further ado, here we go. So what have you guys been up to the last few months? Good question. Now, the good idea, or the good news is, I'm not going to cover everything about this program. We have all of these updates provided online, recordings for all of them, or at least most of them, which you can go and see right here. So that's the link. You'll actually see the recordings. This recording is right there on 22 May 13, but we also have earlier ones. So if you want to go and see the different updates from previous meetings, it's all there for you to take a look at. That's the good news. So what have you guys been up to since January? Well, let's take a look at a few things. One is that unexpectedly, our primary focus has been on conformity assessment and tooling, a 2022 strategy for developing that tooling and those test events. Now we're going to have some subsequent sections and even a whole different presentation on the details of that. But we spent a lot of time, especially in February and March into April, really focused on what can we do today with what we have today and the people that we have today, while still moving in the direction of requirements interoperability support, model-centric specifications, and regulatory submission ready test reports, conformity assessment, and even to certification. So that's been a key area of activity, but we'll have more of that in the coming slides. Now, the other thing we did is recently we completed successfully Plugathon number 8. You got it, kids, number 8. We started this back in October of 2020, and then we went forward into 2021 and now 2022. So every other month in general as we try to complete Plugathon. We have number 9 planned for July. We're working on that. You should see an invite going out from David Gregorchuk pretty soon for that. And then also in those meetings, David captured some example messages, which we have posted. So let's go take a look first at the results of, I'm coming to it. Where did it go? There it is. The results of Plugathon number 8. Now we have all of this information linked from this presentation, but it's all captured on our Confluence site. You'll see here on the left in the menu bar, the May 4 to 6 event, and then you'll see 3 subpages. This interoperability matrix is present on each one of these pages. And so you look at this and you'll see all the different systems that were tested against each other. Remember, a plugathon, an IHE plugathon, is similar to a Fire Connectathon or a Plugfest or an unplug fest if you're wireless, or maybe even a hackathon. It really isn't focused on conformity assessment of an implementation. It really is to build competency, get opportunity to be able to test out some reference implementations that you're building yourself. So as we look at this, you'll notice the different companies that are involved, from including Draeger and Phillips and Vector Test Tooling. They've been working on this recently. Software House, Surgite, and others. Let me see if I can move over a bit here. And notice all of the green. We'll look at that in a minute, but there's a lot of green on there. And the test sequences that are actually being used for this. Those test sequences are also part of the where we posted the notes. So this reference provider consumer page includes now a set of test step message examples. So if you wonder, what exactly does a message look like in SDC or profiled in SDPy? Here is a whole bunch of those messages. When you unload or unzip that zip file, you'll end up with something that looks like this. Hang on a second. A COM log, and you look in that COM log, and you'll see two sets of logged messages. One of those messages is UDP, unsecured, for discovery, and the other is HTTP. And you go into those, and you'll see a long list of message exchanges from Plugathon number 8 that were captured, inbound and outbound. And so, open this a bit more so you can see it. These are all SOAP messages, XML messages, web services for device profile for web services. So when you look at some of these, you'll be able to pull them open and see what they look inside. And I have a couple of them loaded up for you. For example, this is a probe message. One system is looking for somebody else out there saying, is there a certain kind of system out there? And so it's a SOAP message. Notice that the message header here has the not only the SOAP items, but also the 11073 standard extensions and messages from the standards for the 11073 standards. Standard SOAP header here, and it's a probe message. So that's what you see right here. A message ID, and then who it's sent out to. It's a discovery message broadcast. And it's looking for a couple things. In this, it's just looking for medical device types and specific scopes that might be provided in those. Response might look like this, or no, this is another message. Once you've established a secure connection, you can actually do a GET. And so this is the message header is saying, GET, I want to get medical data information from a given provider system. So this is the message ID again, and this is who it is sent to because you have a secure connection. And what you get back is something that looks very familiar. Again, the message ID is responded with. It's a GET response message type, and then the body has all this information that is biceps compatible. And so we look up here at the top and we see IEEE 11073-10207. That's the biceps standard. And so that is what the messages look like. Again, if you download that from the different places that we've posted it, you can take a long time and look at a lot of messages. Notice also that this page has a set of steps. One of the things that we're doing in these plugathons are not only trying out our one system against another system in the implementations, which include, by the way, Python, Java, C++, C#. So there's a big mix of these systems, but we also are identifying what are the test sequences that we end up wanting to use in formal connectathons, IHE connectathon testing later on. And we've linked those to the transactions, active transactions that are in the SDPy 1.0 draft specification. So these are, when we look at the matrix and we say, well, what exactly did happen? These are the different steps. And so we'll go back one more time and look at this and notice that the greens mean they passed all of those steps. Those were where those steps are defined. Some of these are gold or yellow, and that means they passed some, but they didn't pass all of them. I like gold better than red. And that oftentimes has to do with the fact that they're either new implementations or since the last plugathon 2 months before, they've changed things. So it's a work in progress, but it's a great place if you want to be able to get experience working on working with others who have done this and who are there to help you, want you to be able to test against them, to build your own capabilities, to test out your own implementation. Plugathons are great. Let us know if you want to become involved in the next one. Like I said, number 9 is planned for the first week in July, if people are still around in the middle of the summer. We also have looked at demonstrations at the recent HIMSS 22 interoperability showcase, as well as the Berlin DMEA conference recently. So let's look at that. At HIMSS showcase number 22. Let's see. Let me actually pull that up. Hang on a second. We had an isolation point of care use case. And so what I'm going to do is pull up this here. And this is from our notes. We have notes that we do every Friday, for example. We have a 1 or 2 hour call that we work on different things, a Zoom meeting. And in one of those Zoom meetings, this one on April 22nd, we actually had a follow-up example, and you'll see of that showcase. So in March in Orlando, Florida, at the HIMSS Interoperability Showcase, we had an isolation point of care demonstration vignette. The video for that is posted right here. And then we also have materials, in this case from Draeger, who was one of the key participants, along with 2 or 3 other vendors. So go to this link, download that video, look at the other videos, and check it out. Also, you notice that we had a DMEA in Berlin. So connecting to digital health conference, which had a smaller version of that same conference. And at a recent meeting of our Madeira group, we got a report out. This is what that looked like. Let's see if I can blow that up for you. Yeah, this is what it looked like at the Berlin conference. This show ended up being right outside a venue where the conference was, so there was a lot of traffic. It was at least 50% filled most of the time. And you can see in some of our meetings, we actually got a briefing from the University of Aachen and what they did with this demonstrator project here. And then that isolation point of care, a reduced version, is over here on this side. And then some of the other vendors like Draeger that were elsewhere in this conference, when people came up and said, so what are you guys doing next? What's the next big thing? They would send them over here to the or.net booth, and they would get a chance to look at this kind of automation for operating room, as well as this isolation point of care. All of which to say, those demonstrations have been ongoing, and they've been very successful. We are now looking at what do we do for HIMSS 2023. We're going to focus on the silent point of care use case, silent ICU use case. Now, on the technical side, the last few months, we've realized that there's a number of issues that we need to work through. And so our team has taken a topic for distributed alert systems or smart alert systems and has been creating a set of, let's see, where is this? Yeah, has taken this topic for STPI and discussing this. We actually created a Tiger team. All of the discussion is on this page. Keep an eye on that. All these topics, we'll come back and look at this in a few minutes, just the general idea of topics, but they discuss that. Peter Cronick from Philips created a couple of great slide decks. The first one looks at distributed alert systems, and then the second half of it looks at smart alert systems. What are they, but also especially what could go wrong? And for this demonstration that we want to do next year at HIMSS 2023, what are the things we can and want to do? I want to tell you first off that it's normalized with this 60601-1-8 ISO IEC alarm standard. So when you look at the ways things are talked about in here, that's what you'll see. And the first thing Peter does is he looks at, let's see if I can get this to go down. Oh, there we go. Right here. He says, what is the happy case? Okay, where you have a ventilator, infusion pumps, patient monitor. Each one of them has an SDC provider interface, which would provide alerts and alarm conditions. You have an alarm integrator. Again, this is from the 60601-1-8 standard that receives these. And these, and then it also integrates that. It could provide that information to a central station, edge device up here in a relevant alarm communicator, or it could also send it to an edge device that a clinician is wearing. Notice that we've annotated this, that these are edge systems, and this is proprietary protocols for these slides. So if you're used to looking at the IHE-HL7 profile, don't get confused that this is alarm communicator. It's different actor in that profile. Really what we're looking at here is the alarm integrator, and we're focusing in on what happens here. And then what's very interesting is what happens when things break. So one of the things Peter does is including the, hang on a second, including the scenario logic. So each one of these says, for this scenario, when this is the case, when and then the user shall be notified. In this case, notice that it's silent. So we lose this connection here, right? And that can be enunciated here, that it's lost, but we can also show at the individual devices that, by the way, we're not able to get out to the clinician, that AC2 is dropped. Do we want to do that? That's a whole separate question, but we're able to do that. And then also, if we look down here, I think it's slide 14. Actually, I think it's the next one. Yeah, this is one where we actually have an additional one, or maybe I want to look here at smart alerting. So we'll go down here. This is a smart alert subsystem. So how would that work? How would it work when you have not only integration and management of alerts around the point of care, so between the infusion pump, the ventilator, and the patient monitor, to be able to get to a silent point of care, silent ICU bed, but also to be able to have the alarm integrator pull that in, make sure it gets to the right edge devices, but also include a smart alert subsystem. Perhaps that subsystem would be able to look at various conditions, prioritize those, and create its own alert conditions based on all that information. And then be able to forward that on to the edge devices, as well as have that displayed on some of these other devices here. So when we look at that, for example, you might have a smart alert, and deterioration detected may be actually something that this system identifies, but is then displayed on one or more of these devices out here, as well as out here. So that's an example of what we're working through there. And then another one is, what happens when you have multiple distributed alarm systems, DAS systems, if you will? Well, good question. This is what this, oh, hang on a second. This is what that looks like, where you actually might have two systems listening to what's going on at the bedside. One system might be connected to the central station. Another system is connected to remote edge devices or clinicians or other systems. So how does this work, and how do you make sure that there's coherency? And oh, by the way, what happens when some of these connections are dropped? So remember, there's a lot of slides that say, oh shoot, we've lost this or we've lost that. Maybe you lose the entire alarm integrator 2 system, or the alarm integrator 1 goes offline. How do we handle that? And then again, if I look at slide 14, that's the number that sticks in my head. No, that's not the right one. Let's see if I can go back here, or maybe here. Sorry for not having this identified clearly. Oh, here it is. What happens, perhaps, especially if you have a smart system, maybe instead of having these separate or have redundancy here, you might actually have the alarm integrator provide an SDC feed for those alerts that need to go out to remote connections. So there's all sorts of discussions around this. As you can see, This is a lot of discussion that's going on the technical side. We're also working on that in the ecosystem pathway group side. So a lot of work's going on. Is really focused toward what do we need to have in place from a technical spec wise, from a use case scenario wise, from an ecosystem pathway quality and risk management perspective to be able to do that demonstration. A lot of work in the last few months has gone on, and there's a lot more still to do. We've also been working on a sustainable business model or an accelerator, and options are being evaluated for the Gemini SES+MDI program longer term. Remember, we created a white paper in 2019. We published it as part of the IHE devices white paper selection saying, how might we do SDC, ISO IEEE 11073, service-oriented device connectivity standards profiling in IHE. And then that became this Gemini project, joint IHE-HL7 project, early in 2020. Since then, it's been this Gemini project, but now we have companies that are actively working on product plans and strategies, and it's no longer good enough to be able to have a guess as to when this volunteer work will complete, but be able to have product plans that say, yes, we'll hit testing, we'll have these specs in place, we'll be able to move forward in a more deterministic way. We've been talking about that. I have a next couple slides on that, but a lot of work the last few months on doing that. I will say that we had Plan A last year in the September update, even the January update, but it was clear by the middle and end of January that wasn't going to happen. So we've gone to a Plan B, and I'll talk about that in a second. And I'm very, very positive and confident that that will play out. We have topics of interest. That list gets updated all the time. That's good news or bad news. Bad news in the sense that we're not knocking them down as fast as we should, but good news in that they're coming. And the prioritization of those and getting those resolutions done, those are happening very actively. We'll talk about that also in a subsequent section. Notice that also we have the upcoming IHE Global Connectathon in September. And we've talked about maybe having a hybrid SD-Pi Connectathon just for that profile late this year, maybe early next year. So in that Global Connectathon, one of the questions has been, will we be able to have a presence? This is the IHE Europe Connectathon. This is the week of September 12th to 16th. This is actually an in-person Connectathon in Montreux, Switzerland. And there's also planned an IHE USA Connectathon, probably in Atlanta, the exact same week. Just to note, the following week are the IEEE IHE-HL7 joint meetings, working group meetings. So it's a lot together. We are thinking of having, we will plan on having our Plugathon number 10 that same week. But it may be hybrid in Germany. It might be totally virtual depending on COVID. And we hope to be able to participate at least in the conferences, the IHE Europe Experience Day, which is right here. If you click on that, you'll see that day, as well as the IHE USA Connectathon Conference. So those are both works in progress. And we hope to be able to have at least some presence again this coming September. Remember that in the IHE European Experience June of 21 last year, we had a presentation that's part of that. It's been a great presentation that Dr. Stefan Schlichting and I did about conformity assessment and using IHE Catalyst. The Madeira profile activities, we continue our monthly discussions, and it's especially relevant to the ecosystem pathways, safe, effective, and secure technology discussions. These are all recorded on this webpage here, and you should be familiar with this. And this kind of gives you a reminder. So some people, if you want to try to remember, what is this? We have all of those graphics on here. The key resources that have been published are linked on here. We have the actor model for the profile. When we get to developing the profile, this is where that's at. And we also have all of our notes. So if you come down here to the discussion notes, you will see the meetings. We have an archive, right, for what was happened last year, but these are the 2022 meetings. Once a month, we touch base, and we're working on what are the issues. There is a topic of interest table that we're maintaining, and we keep that discussion alive. We have to finish SDPI first because the Madeira profile is built on top of that. But that doesn't mean we have to wait to identify issues, to identify opportunities and project opportunities. So if that's of interest to you, let me know and I will be able to get you plugged into that. So those discussions continue. When I say this is especially relevant for the ecosystem pathway group, I mean that group is looking at how can we ensure the quality, the risk management, reliability, even the regulatory affairs for these technologies, this ecosystem of plug and trust products, components when they're deployed. And that is specifically the key area that the Madeira reference architecture addresses, is the health of those networks, as well as autonomous and semi-autonomous medical care systems. So hopefully the EP discussions will build the need and the case for implementing Madeira and thus being able to have some actors and technologies that will take that dynamic real-time network health to the next level. Okay, enough of that. Let's see. We've been working with IEEE 11073 coordination, especially the 11073 10700 participant key purposes implementation files. Now, or the standards, and then we're looking at how does that get implemented within the SDPI profiles. Short to say, we take the implementation conformance statement table from each one of those 4 participant key purpose standards, that's 10700, 01, 02, and 03, and we put that in Appendix B of the SDPI Technical Framework Volume 1, and then we say, how do the requirements from that get implemented in SDPI or not? Some of them aren't implementable in technology. They require inspection and documentation. We also have been working with the 11073 SDC standards groups to identify extensions and fixes, things that need to be updated in the standard, but that might take a couple of years to get to. But we can profile those fixes and those extensions today. So there's a lot of collaborative work that's ongoing with the IEEE 11073 SDC point of care devices subgroup and committee. And then finally, we have 2 new profile or standards, projects within HL7 that we are just finishing up, maybe very soon, approval for. And we'll take a quick look at this. The first one, 1980, is probably a familiar one. Hang on a second. And that is a covering project for this Gemini work within HL7. Now you might say, wait, we started this in March or so of 2020. We haven't done this yet. Well, that's absolutely correct. We got it started back then. We finished it on the IHE side. But if you remember, a few things were going on then. HL7 was moving its whole tool base from being a wiki-based and to Confluence, for adding Jira in the middle of that, figuring out how do we want to use Jira. And then also the processes. So where do we do project scope statements? Is that still a Word document? Is that a Confluence page? Is it a Jira thing? That whole process was in motion. So though we got started and though we got a project proposal started, we never got it all the way completed. So, and then we got busy because that work was in flux, constant flux, the whole process and the tooling. And then COVID happened and things were in total disarray. So we basically got busy with the work, waiting for things to settle out within the HL7 PSS world to finish this off. Well, the PSS police found us and said, what are you doing? You never finished this. So we've come back around and we put this together. We took the profile or the project proposal approval, and we created this, and now it's out for review. Notice that it was started on March 7th is when we created it. It closes on May 24th. So then we will be able to see, we'll have an official project. That's good news. The bad news is we'll also have milestones that we have to meet for that. So that's one. The other one is a device alerting project that we started. So we recently launched this before we said, this might be in the second revision of the HL7 Fire Implementation Guide for point-of-care devices. But as we looked at this, the device alerting subject, we realized it's bigger than that. It's something that really deserves its own project. So we launched this separate project, Device Alerting, DEVIL, great acronym. Devil is always in the details, especially when it's device alarms. And I'm really happy to report that it also closes on May 24th, but we have great participation because not only is it HL7 devices and our IHE and IEEE counterparts, but Orders and Observations wants to be part of this, patient care, as well as clinical decision support. So they will be actively participating in it, monitoring the project, and that is huge to be able to have that participation in it. Just like the slides I showed you earlier on the DAS and Smart DAS and multi-DAS systems that Peter Cronick did, this here is aligned with 60601-1-8. We also make sure that we have clear coordination with the IHE devices alert communication management profile, which uses the same 11073 semantics, but HL7 version 2 messaging. So this will really cover all of that ground and result in not only having a fire implementation guide for this topic, but then that will be leveraged in some of the other implementation guides in HL7 as well as in IHE devices. So with that, I think that covers the broad picture of what we've done. I want to spend a few moments though talking about HL7 now and a Gemini program within HL7. Where does that happen? You may have seen this updated framework for how HL7 processes and artifacts and groups are now working together. It comes out of the HL7 re-envisioning process. Remember that for the last, I think, 2 years or so, HL7 has said we have to get better at what we're doing. And if you look at this on the web, you'll find all sorts of great documents that go into how HL7 has done this process, what they've reorganized now, and what it looks like going forward. Taking the stuff that was working, but then refactoring that, reworking that, so that we're able to be able to do so in a much more coordinated, efficient, firmer foundation way. But this is for HL7. Notice that part of that re-envisioning included 2 new executive positions. One is Dan Vreeman, who is the Chief Standards Development Officer. Dan really looks after this gold part on this framework itself. How do we go about developing specifications, balloting specifications, resolving and updating those, and then publishing those? That's really the core of what HL7 has done historically and what we've worked on extensively. But then there's the Viet Nguyen, who is the Chief Standards Implementation Officer. He is focused on this green stuff, right? So how do you build that community? So the green and the black, if you will. How do you build that community? How do you then go into project planning and accelerator groups? Hold that idea. Create accelerators, as well as get some reference implementations development going, and do fire connectathon testing. Notice the synergy between those and getting that feedback back into the whole process. So this is the building community, which then informs the standards development part. But at the end, we want to not only be able to support pilot projects, but we'll have a reference implementation as an expected deliverable for each one of these projects. Educational materials, guidance for best practices will really support the implementation community. So do we have an implementation community? Can we really support it? And then making sure the standards really fit those endpoints. We're looking forward to Dan and Viet working with them closely, but that's within HL7. How do joint IHE-HL7 Gemini projects work with the IHE processes as well as the HL7, with IHE tooling as well as HL7 tooling, with IHE connectathons and conformity assessment, along with fire connectathons and HL7 testing, reference implementations on both sides. That is an ongoing discussion. And I can tell you that what we're working on specifically is a Gemini Safe, Effective, and Secure, plus Medical Device Interoperability Program Accelerator. So remember I said we are working on a long-term way of supporting those organizations that have product plans. They need to know when things will be available, and they would be willing to fund an accelerator program to be able to ensure that the right resources are able to work against a roadmap and a timeline that is important to their companies. So we're working on that. And how do you do that jointly between IHE and HL7? Who plays which role? Come hopefully by the end of June, definitely this summer, we'll be able to have some proposals for you, and you'll be able to see if that works for your organization. Putting together the roadmap, pulling the funding that's necessary to achieve that roadmap, and moving forward with that. So those are the discussions that's going on, and I'm very, very encouraged with how that is playing out and how that will help us. So with that, for this presentation now, which we're already 35 minutes into, I will give you a little sneak preview on this a key area that we've been working on, which is a strategy for conformity assessment and tooling with what we have today. So 2022 strategy. That said, I have over 100 slides in this presentation. So I will give that presentation separately. You don't have to listen through all of that now. But I can tell you that we look in that presentation at reality. What is the baseline that we could do? And what are the tools available? How might we use those today to start down the road toward RIMCRR and then expand that in 2023, 2024, and get to where we need to have product conformity assessment down the road, getting to that regulatory submission ready value proposition that we've talked about. So I will present this on that library page in a separate recording and go to a lot more detail on that. Let's just say that we did not plan on doing that, but it was very clear in February that we needed to do that, and it's been a very, very positive effort, and we're almost done with that. So another thing that's happened since January is the Safe, Effective, and Secure Ecosystem Pathway Group that we launched. Now, we put it on the table, this idea, last September. In January, we reported out what some of the leadership had gotten to in thinking about how that happens. Well, it turns out that in February, we actually launched that EP group, and we have a Confluence page, of course, that captures all of that information. So what I'm going to do right now is just give you a really quick tour of what that Confluence page looks like. So this is a page right here. And if you wonder, what in the world are you talking about establishing a pathway to an ecosystem of plug and trust products? We call it the EP group or the Ecosystem Pathway Group. There's a lot of detail at the top of this page. It just helps you come into that. But remember that MDI, the MDI part you see right here, is focused on technical medical device interoperability. That's really the key area. Whereas getting any product to the market, actually in patient use, requires the safe, effective, and secure, the quality, the risk management, the regulatory affairs aspects to be in parallel developed. It's not good enough to have a solution. You need to have a solution that everybody can implement, get into product, get through conformity assessment, and be able to put it into on patient use within a plug and trust ecosystem of products that are developed by different manufacturers around the world at different times. How hard can that be? We actually have a very clear pathway for that, but this group is focused on those whose day job is quality, risk management, regulatory affairs, that part of it. So we were very busy since January, and we actually now have gotten to where we have, this is a lot of discussion here, to where we actually have a number of pages. And if you look here on the left, I'm going to open it up. Here are all of the discussions that we've had, okay? And we have those every week, or twice every other week is the regular cadence. And if you look at the discussion page here, you will see, and it's coming. Takes it a while to load. I'll take a drink and a breath while that's happening. I will say that Microsoft Edge on a Microsoft platform runs a lot slower than Chrome. So we have all the notes from these discussions. If you're interested in anything, come and look at these. I think you'll find them very interesting. For example, we already looked at this one here. Actually, no, I want to go back and look at that one is, I want to look at the previous one. Hang on. Microsoft Edge. This one right here. So this is the one that we had late April, and it was a very interesting discussion. And we're working on various things. Right now, we're working on a glossary, for example, but there were presentations. So this is what it looks like. Just general updates, and then linked other posts to give you general updates. But we have 2 presentations that were made at a Brussels Regulatory Affairs Conference and discussion around that. And then we also looked at how might we do conformity assessment and tooling and that strategy. We'll look at that in that other presentation. And that device smart alerting challenge. So it's very important when you're talking about SES and regulatory affairs and risk management, you don't talk in the abstract. You really talk about specific devices and specific use case scenarios. So since our focus for early 2023 is silent ICU, guess what our focus is in this group for doing that quality risk management regulatory affairs? It's all around that. And so we had that discussion. So you can go and look at this for all of those notes. Like I said, we are really interested in anyone who is in that group within your organization. So again, quality, conformance, testing, risk management, regulatory affairs, any of that. The they're technical, but their really day job is making sure the product is safe, effective, secure, and ready to be put into use on patients. Anybody like that, send them my way, and I will get them plugged into this discussion. By the way, the stakeholders in this discussion include those from medical device manufacturers, experts in those groups, as well as European notified bodies, as well as some FDA participants and others. So it's a good mix. It's a very good mix. Okay, let's see what's next. Okay, topics of interest. Now, this is not new. You may remember that we created these topics of interest table from January. Go and look at that, but I talked about these. We actually have 3 of these, and this slide is from that January update. We have one for the technical side. We have one for the Madeira profile. So as we identify key issues within that Madeira discussion, we capture it. So when it comes time to fire it up and move forward, we're not saying what was that issue that we identified. And then the ecosystem pathway table as well. But we refined it and we continually fill it out. As you can see here, this is the technical one from the topics on the table for the SD-PI that we work through every week. And what we did though is we identified what does that artifacts look like, the deliverables. So here's a little graphic. Guy has a great idea. In a meeting, it's like, I wonder how we're going to do that. It's a topic. He shares it in a meeting discussion. They're like, you know what? That's a good question. That's something we really need to look into. So we capture it in the topics of interest table. And then we discuss it at our weekly meetings. And we capture all of those discussions on that page. And then we also link those meeting discussions and other meetings, all of that into the topic discussion pages. And at some point we say, you know what? We have it. We come to a consensus agreement of those experts in this area about how we should address that issue. And what are there specific requirements or guidelines, and how are we going to actually implement that? We update the topics of interest table and we update that, say the topic is resolved, and then we identify what are the formalized artifacts that have to get generated in response to resolving this topic. All of which is publicly captured and publicly available. In this case, the ecosystem pathway plug and trust products, you'll see that table on there. We have them for Madeira as well as the SD-PI technical stuff. And we put it, all of those resolutions in the GitHub repository, and those get linked into the actual SDPI open and closed issues table. So all of that said, this is the organization of that, and it's served us very, very well. And if you have any questions or you're wondering, well, what are the issues you guys are working with, go to these. I have these linked on each one of these pages, so you can go there and check that out. Actually, I think I do have that linked here. Yep. And I'll just show you a couple of these. We have this at the top of the page, and as you go down that page, you'll see some of the topics. One of the key ones we're going to look at is what information is exchanged during unsecured discovery. So pretty early on, we go into secure mode to ensure that there's no inadvertent disclosure of information from one device, one SDPI system to another. But you have to discover each other to be able to make that connection. What kind of information can you, and is it sufficient? So that's one of the areas that we've been working through. And you can see some of these are initiating, some are discussing, they're prioritized. One is high, that means we can't do SDPI 1.0 without resolving this. Some are medium, yes or no. Some are, yeah, when we get to it, 3, and some are, yeah, in the future sometime. But we capture all of them, and they each have their own page for resolving. So I'm going to bring this up right now, and we'll look at this in a few minutes. So that said, that's what we have here. It's become very, very useful for us, and we're really appreciating using that. Now let's look at updating IHE devices, OIDs, object identifiers, and how we might use those to support SDPI extensions. One of those topics that we looked at, the SDPI biceps extension namespace, resulted from trying to look at options to resolve this particular issue. So if I go back to look at that information exchanged, where is that? Right down here. So I'll just click on that page, slowly bring that up. If I look at this, and we talked about this, we said, how do we want to do that? How do we know how much needs to be done? And we came up with a solution, but it also required an extension to the 11073-10207 biceps standard to be able to say there's an extension to that, to the model. And so we actually looked at that, and we decided that we needed to have an attribute that's not in the biceps model, but that we can include an identifier in that discovery message to say, by the way, is there anybody out there that has this label on it? It's just a label. It's a label that a given hospital might stick on their device to be able to identify it. But there was nothing in the biceps standard to do that. So yes, there is a ticket against the biceps 11073-10207 to add this concept, but we need to move forward more quickly. So when you look at this message, this is just an example message, and you look at the response here, notice that that response includes an SDPI extension. An SDPI biceps extension is identified. Well, okay, that's a good solution, but how do we want to do that for all time? How do we want to signal in the header of the message that this has biceps extensions? And then notice, once we have that extension called out, we can say in the MDS, there's an extension, and this is the extension itself, and we can add that in. So we need not only to profile what that extension is for each case, in this case, the soft ID, but we need something in the namespace to be able to capture that. Well, when we talked through that, we realized that that's an issue. It's not just that one instance, it's a general purpose issue. So what happens when you get a general purpose issue? You create a new extension. So that's what we did, or a new topic. And so that's what we did. And if you look at the next page loaded here, you'll see that that's a topic we created, SDPI biceps extension namespace. And we came up with all sorts of different ideas. and this is one of the proposals that David Gregorchek provided. We looked at different options, different examples of those. What exists today? How is this done within IHE, for example? What if we use a URL? We gave an example from the IHE-ITI mobile access to health documents profile, and which uses these. And we said, well, maybe this is what that would look like. This kind of identifier string, which we could then use for all sorts of other extensions and identifiers. Maybe we want to use an OID-based namespace instead of a URL, for example. Maybe we want to have it use the root for in IHE devices or PCD along these lines here. So by the way, the root OID for PCD is this here. That's been assigned. It's in active use. We'll look at that in a moment. And maybe we just want to extend that in a natural way. Maybe we want to use the current PCD OID organization and add something to that and allocate a bunch of stuff for SDPI. We ended up deciding on, or maybe we just want to use a URN. This is the last for an IHE namespace code. Again, when you look at IHE.NET Fire for format codes, you see a table. And this table here defines a bunch of extensions like this. So a URN, IHE, ITI, cross-enterprise document workflow, cross-enterprise, yeah, document workflow. I'm pretty sure that's what that is. Or this is for that document. So this is a way of doing all of those. Maybe we want to take that approach. After looking at it, we did come up with an approved way. And if you look at the next notes, so these notes, when we decided and looked at the options on one of those Friday sessions, we ended up saying, oh yeah, this is it. And we documented it. So on April 8th, in our SDPI Friday, we had that topic of interest review. We looked at that extension namespace topic, and we made this decision. We proposed to the IHE devices co-chairs for consideration at the upcoming IHE devices PCD spring meetings, which was the end of April, to change the PCD OID management page and content. We'll look at that in a minute, to reflect the action item below. We looked at it, by the way, and we realized that though that was the best, easiest way, those OIDs were kind of behind the times and needed to be updated. So, and we capture all of that discussion. So the proposal is that we actually update the management page, that we change PCD to dev, which is something we changed the devices at the end of 19. So we're a few years behind on that, but obviously we've been able to live with that. That we analyze and update to reflect the current profiles, actors, and transactions. So we realized that actually, forget SDPI, that there's other IHE profiles that need to be updated into here. And then to be able to add to that table this information here. So that was the discussion. That was the decision we made. If we just look at this, by the way, this is the linked table here. And I think actually, if I look back at this, you will see that, yeah, that's when the fun really began, because we then looked at this table. We looked at the parent, IHE in general OID registration, and realized that it was a bit behind the times. And so this is, again, the page. This needs to become IHE dev, or dev OID management. And you'll see that we'll add to this a little history so people don't get confused. But these are the tables. These are identifiers we're talking about. General ones for OID identifiers for dev, and then for specific framework volumes, specific profiles, specific actors, specific transactions, and IHE PCD interactions, which are special. And then for conformance, if you're doing conformance testing, there was a bunch of OIDs defined for that. And even for the Rosetta terminology mapping. So this page will get updated and then extended. I think we also, that's next. So that's where we ended up with on that. A second. And that'll be coming soon. So we were very busy, but this shows you how working through a topic, an issue, an idea spawned another topic, how we discussed that, how we came to a resolution, how we coordinated that with both IHE and HL7, the leadership, and how we came up with an action plan, and now we're going through and executing that. That is a great example of how we're being able to move this forward. This is a proposal. I forgot that I put it on here. And as you saw, that's where it is in the discussion notes there. And John Rhodes and I are now tasked with finishing this off and presenting it to the IHE Devices leadership, since it's their pages, for a review, and then putting it out for approval by the IHE Dev membership. Okay, the last thing for today is the fact that we've been using IHE GitHub for the SDPI-Fire, that repository, for quite a while, since early 2020. And it seemed, though, for a long time that that was the only one there. But in recent weeks and months, we actually see that the use of GitHub is more and more the norm. And that includes publication of artifacts from an IHE GitHub to profiles.ihe.net. That has become even more integrated. So when I talk about GitHub profile or GitHub repositories, IHE Devices as a domain, all of its work is in a technical framework repository. We have the one for SDPI-Fire repository, again, an IHE Gemini project. This new program, 2005 Device Alerting Project, DEVIL, has a new repo for all the artifacts that will generate within that project. The NIST tool that we're looking to use for that strategy, that 2022 conformity assessment and tooling strategy, those both reside in NIST GitHub repositories. One asbestos for the fire toolkit, as well as the XDS toolkit that we've used for many, many years. And there's an IHE publications repository, and it's from that repository that all of the publications are generated, including the IHE, the profiles.ihe.net devices work. And the cool thing about that devices is that it's brand new. So we just recently brought on, created this. So take a quick look. This is hot off the presses, like days ago. Mary Youngers, thank you very much, Mary, took the information which is on the IHE Technical Frameworks webpage for devices and put it on our own profiles.ihe.net dev page. Has the same information here. These link to the actual PDF documents. Notice it still says PCD because even though we changed the domain name in 19, because of all the activity and what's been going on and things like COVID, we haven't published a dev technical framework. That should happen sometime in the coming months. And when that happens, then we'll see this change here to dev technical framework 1, 2, and 3. Notice that we also have all the supplements are in there, as well as handbooks, as well as white papers, including recent versions. Notice the service-oriented one that I talked about in Ken Fuchs' compendium of use cases is down here at the bottom. We would anticipate some of the other work within SDPI being also linked on this page. Profile-specific things, or things like the OIDs, the updated OIDs, we would see that being persisted here and available here. I just want to spend a moment taking a look at this. Notice that if you come to the home, so this is profiles.ihe.net, there's only a few domains that have any sort of presence here. And really, IHE ITI infrastructure is the main one. And this one here is a great one to look at to see what might this publication look like. Notice that it has the technical framework, profiles, transactions. It has topics, key topics. For example, document sharing, health information exchange, a white paper for that, and the profiles around document sharing. So document sharing is the key thing. And then public comment, and then the supplements that are out there. But if I were to look here at the technical framework, where is that technical framework again? Right here. Notice that it actually has the volumes. And then if you go into those volumes, you see that information in HTML published from that IHE Publications repository. And in here, you can look at each one of the profiles. And let's just look at this. And this gives you the same information you would see in the PDF document, but you can navigate it in HTML. So it's a great, great thing that we're able to do there. And then if I go back up here, again to ITI, I'll just show you how to navigate to that other area. So remember that format code vocabulary, that's right here. And if I go there, you'll see a number of different vocabularies and other things that get defined that we want to use within the profiles. And I'm going to look at value sets. IHE defined value sets. And this is where ITI has defined those in these kind of tables. And I would see using these same kind of tables for the value sets for the artifacts that we need to publish and make persistent and available for whoever is implementing any of our profiles in this Gemini project. So we'll leverage our inner ITI and this profiles.it.net/dev pages, and we'll do that to great benefit, I think. With that, I think we are done for this update. Let me go back to the presentation. Yes, we are. Like I said, I will do a separate one that goes on a drill down on the conformity assessment and tooling strategy development. If you have any questions from this May 22 update, send me a line, Todd Cooper, toddcooperafc@gmail.com. That's AFC, America's finest city. Thank you very much, and look forward to seeing you in some of the meetings coming up of the Gemini SES+MDI project.